Coming to frame section property data, so here we need to define section properties like column size, beam size, and slab thickness. So first I'll define column. Here I'll be naming test C. C stands for column and score 200 by 600 and M30. So 200 by 300, 200 by 600 column size, and M30 is concrete grade. So going to material, select M30, and coming to sizes, depth will be, always keep in mind for depth give the maximum major axis dimension of the members. For columns, in our case it is 600 and 200. So coming to modify or show rebar, here you can see in the design type as whether it is column or beam. For column it will be considering axial force and moments in major axis and minor axis direction, and for beam it will be M3 only. So since we are defining it as a column, so I'll return as it is. Coming to longitudinal bars, so as I said earlier, main steel if it is Fe500, and confinement bars or ties it is Fe415. So rest all other parameters I'll return it as it is. So we can modify it later as well. Give OK. OK. Similarly, add new property, concrete rectangular, and define beam size. B stands for B, 200 by 450, M25. So here it is material M25, and coming to the size it is 200 by 450, and then modify or show rebar, here M3 and Fe500 and Fe415. You can just observe here, once you changed from column to beam, so the reinforcement parameters it will not ask only, we need to mention cover. So all these parameters here governs for the design. Give OK. Okay. So now I need to define slab. For that, go to define section properties, slab sections, add new property, and here I'll name it as 150 thick slab. Here also you can give it a mention grade of concrete as well as M25. So in the material, select M25, let it be shell thin only, and type slab, and here 150 mm. Give OK. So now we have defined material properties and section properties. Now we can create geometry. First, to draw the columns, so either you can use the icon that is available in the left side. So for creating modeling, we have for the line elements like beams and columns, we can draw by using any of these three options. That is, first option, draw beam or column or brace, plan, elevation or 3D, and second one is quick draw beams, and third one is quick draw columns. So here the third option is only for the columns, and that too wherever grid lines are provided, grid line intersections, there only you can add the columns. Whereas the first option is anywhere you can draw beam or column, whether it is within the grid lines or in any space you can draw the element, that is line element. It need not be beam or column. And coming to this second option, it is quick draw beam or columns. So wherever grid lines are available, there only you can draw the line element. So the same is available under draw menu also. If you go to draw, you have draw beam, column or brace objects. The same thing you can see here as well. So first I need to draw the column. For that I'll select this quick draw column, and then in this properties of object, select property. Here the property I need to select is column. So select column 200 by 600 M30. You can just close this. Then So wherever grid, as I said, wherever grid lines are intersecting, there you can add the columns. But if you observe, if you draw the columns in the right side window, if you see in the 3D view, only at the topmost floor the columns are added. This is because at the bottom you can see this one story. So here whatever you update, it will geometry or any property updates, it will be applicable for one story only. So if you want for entire level, just select here, click on all stories. So I'll just select all the column and then I'll just delete it, and I will draw new column. So it is now, it is in all stories only. So column property selected, I'll just drag the window. Now if you see in 3D, so columns are added for all levels. Similarly, I'll draw the beams. For that I'll select the second option, go to frame and property, beam. So now I will just drag the window. So now it is added to all the levels. Similarly, I can add slabs. For the slabs we have similar to line element, we have three options. I'll just select the third one, and here slab property is 150 thick slab. Same thing, I'll just drag the window. I'll just close this. Here since it is in all stories, the slab is drawn to the base level as well as to the plinth level. I need to delete slabs at these two levels. For that I'll just change this to one story, and if you see in the plan, it is, you can read here, plan view terrace z equals 19.5. I want to go to base level and plinth level and delete the slabs. For that you can either click on this plan and then select base. So the plan view will change to this base level, and click on this select object, and I'll just select these slabs and then I'll just delete it. Similarly, I need to delete in plinth level also. For that either I can go, as I selected for from plan, I can go here and then select plinth level, or else you can see this arrow, I'll just click move up in the list, then it will go one level above. So plinth level z equals 1.5. Here I'll select only the slabs and click on delete. So the slab at base level and plinth level I have deleted. Then next thing is I need to assign the support. By default the support will be pinned support, it will be assigned. Just right click on any support, you can see restraints, UX, UI, UZ. So but I need to apply it as fixed support. For that select the supports, go to assign, joint, restraints, and click on fast. In the fast restraints you can select fixed, click OK. So now the support is assigned as fixed. Just right click on this, you can see UX, UI, UZ and RX, RY, RZ are restrained. So now the model is ready. So the loads we need to apply. So coming to this 3D view, we can extrude and view the element sizes as well. For that, so what I'll do is, we have this set display options, click here, click on extrude frames, give OK. You can see here columns and beams and slabs. Fine. So what I'll do is I'll just save this model. Yeah. So I have saved the model. Now I need to define and apply loads. So before applying the loads, we need to define the load patterns. For that, go to define. We have load patterns. Click on load pattern. By default, you have dead and live in the load pattern. These two will be predefined. And coming to dead load, so first column will be load naming and second one will be type, that is grouping of the load, and the third column is self-weight multiplier. If you see, for the dead load, self-weight multiplier is 1, whereas for the live it is 0. So this self-weight multiplier 1, that stands for, so whatever we are modeling, whatever geometry we are modeling, based on the material self-weight, material density and section size, it will software will automatically calculate self-weight of the structure. For that, this self-weight multiplier 1 is given for the dead load, whereas for all other load cases it should be 0. So what we generally do is, in the dead load will be considering only self-weight. Apart from self-weight, all other load like floor finish, wall load, everything will be applied, will apply in separate load patterns. So we'll create separate load pattern like SIDL, where SIDL stands for superimposed dead load, and then we'll apply in that particular load pattern. Here I'll name it as SIDL, then type as super dead, self-weight multiplier will be 0, and add new load. So anyways, live load is already there. Give OK. So here I need to apply floor finish and live load on the slabs. So here I need to select the slabs. For that, go to select, again select, in this go to object type and click on floors. Select. So all this slabs at all the levels will be selected. So you can read here 54 shells. So in each level we have 9 slabs, 9 into 6. So 6 nines are 54. So 54 slabs have been selected. Go to assign, shell loads, uniform. In this drop down, select SIDL and floor finish is 2 kN per meter square. Give apply. Click on apply. So you can read in this window. So plan view, ground Z equals 4.5, uniform load gravity SIDL, and the intensity is mentioned above the slab. So same thing will be visible at all levels. Now I need to apply live load on the slabs. Similarly, similar to how we selected the slab previously, again we can select this in the similar way. So for that, go to select, object type, floors. So here select live load and give the intensity as 3 kN per meter square. Click OK. Just right click on any of the slab, so to cross check whether the loads are applied correctly. So you can see this geometry assignments and loads. Click on loads. Here you can see the loads applied on each slab. So we can see here live load applied as 3 kN per meter square and SIDL 2 kN per meter square. Click OK. Now if you have any wall load coming on the structure, that one you can calculate and then apply. So here on all the beams, I'll just, for the analysis sake, I'll be applying 12 kN per meter UDL on all the beams. To select only beams, go to select, again select object type and select beams and select. So all the beams are selected. Then go to assign and frame loads distributed, and in the load pattern name select SIDL, and since we are applying it as uniformly distributed load, go to uniform load and give the intensity as 12. Click OK. So you can see the 12 kilonewton per meter is applied on all the beams. You can view it in 3D view also. Just click on 3D. So the loads are shown as UDL. So click on, I'll just click, go to plan itself. So I'll save the model. So we have applied dead load and live load. Next is I'll go for seismic loading. So seismic load, we'll be doing seismic analysis in two ways. One is static method and the other one is dynamic. Static is nothing but equivalent static method, where we need to define zone factor and type of soil and response reduction factor. And load pattern, for this case we need to define into both the directions, in the x direction as well as in y direction. And coming to dynamic, it is time dependent. There are two methods where we can perform dynamic analysis. One is response spectrum method as per codal provisions, and the other one is time history method based on previous earthquake time history data. So coming to equivalent static earthquake loading, go to define load pattern. Here I'll name it as EQX, that is equivalent static in x direction. Coming to type, it is seismic. Sulfate multiplier will be 0, and auto lateral load, here you need to select the code which you will be referring to. So IS 1893 2016, add new load. So click on modify lateral load. Here I'll be considering for x direction, so I'll just remove for y direction. And zone factor is for zone 2, so Z value will be 0.1, and soil type will be hard, that is 3, and importance factor as 1 only I'll consider, and response reduction factor 3. Click OK. Similarly EQ Y I'll define. So type will be seismic, same thing, auto lateral load, add new load, again modify lateral load. Instead of x I'll retain for y, and Z value will be 0.1, and soil type hard, response reduction 3, and OK. So for seismic, in addition to defining load patterns, we also need to define diaphragm actions, that is for seismic as well as wind load, and mass source. So to define diaphragms, go to define diaphragm. So by default already D1 will be there, so go to modify, so let it be rigid diaphragm, click OK. So to assign diaphragms, select all the slabs, go to select, object type, floors, select. So all the slabs will be selected, go to assign, shell. In this, click on diaphragm, select D1, OK. So you can see this is the diaphragm point, where this seismic wind load will be applied to this diaphragm location, and it will be distributed to the columns based on the stiffness. Now to define mass source, go to define mass source, and already mass source is there. I'll just click on modify. So I'll just remove these two. Instead of elements self mass and additional mass, I'll select specified load patterns. So here dead load I'll be considering 100%, so multiplier will be 1, and SIDL, that is floor finish wall load, 100%. And coming to live load, if live load intensity is less than 3 kN per meter square, the multiplier will be 0.25, that is 25%. And if it is greater than 3 kN per meter square, we need to consider 50% of the live load. So since it is 3 kN per meter square, I'll be considering 25%, so 0.25. Click on add and OK. So I'll save the model. So now we have defined dead load, live load, SIDL, and equivalent static earthquake in X and Y direction. So I can run the analysis and check the behavior. For that, either you can click this icon, run analysis F5, or go to analyze and run analysis. So now the analysis is done. So this is dead load deflection. So go to display, deform shape. So I'll check. So dead load, live load, SIDL, the deflection shape will be similar one. So I'll check for earthquake loading. The drop down, select EQX, click on OK. So we can see the animated view. For that, at the right side bottom you have start animation. Click on start animation. So click on animation. So next we'll be applying wind load, that is static loading, and then I'll be letting you know how to perform dynamic analysis using response spectrum method and time history method. So I'll be closing for today's class. Thank you.